Hi, welcome to Mindset Learn Extra Live. Today we're doing grade 11 maths with Dina. Dina, we're doing trigonometry, right?
Yes, we're looking at the trig functions today, so it's all about angles and graphs.
Ooh, that sounds exciting. Guys, remember our show is brought to you by Liberty. Thank you so much. Liberty rocks. Remember to send through all your questions and comments on our Facebook page, facebook.com/learnextra, and our Twitter handle is @learnextra. Guys, get refreshed, get some water, some food, and we'll see you after the break. Hi, welcome back, Mindsetters. Hope you guys are refreshed from your break. Remember to send in all your questions and answers and helping each other. And remember, today we're with Dina on grade 11 maths. Over to you, Dina.
Thanks a lot, Kletlego. Well, welcome everyone to some grade 11 trig functions. I'm going to review some of the grade 10s, and that's the foundations, the basis for what we're going to carry on with in terms of some changes or some transformations in grade 11. So let's get right to it. Let's have a look at the first function, y equals sine x. We'll later on look at the y equals cos x, and we'll later on look at y equals tan x, and look at the transformations that exist around those trig functions. So the first one we'd like to look at is, what do you remember about the y equals sine x function in terms of its position on a graph? So let's have a look on the board. Firstly, the sine function oscillates, and we have plotted this function between negative 360 degrees and 360 degrees. Now, last year in grade 10, you would have only used maybe 360 degrees from 0 to 360, but in grade 11, you would have worked with negative angles, and those angles can exist from negative infinity to positive infinity, and I'm only going to look at a section of that domain, and we're going to look at negative 360 to 360 and see how the graph actually changes. So let's have a look again on the board. Right, so the sine function oscillates, and we have a maximum value at 1, and we've got a minimum value of negative 1. So the key features of the sine graph is that its domain could be the real numbers. However, the range of our function, your trig ratios all go from negative 1 all the way through to 1. And the region from where the function starts, it then travels through to a maximum of 1 at 90 degrees. We then have it decreasing to 180. We then go through to a minimum at 270, and then we reach 0 again. Once it reaches this point, it will now repeat its function again. And so this distance here, let's make it in green, this region here shows something unique about that function, and that is that the period is 360 degrees. So it takes 360 degrees for a particular curve to repeat itself. So if I started over here at 90 degrees and I went all the way through to the next 90 degrees, it would still take me 360 degrees for me to see the next maximum. So the curve repeats its position or its y value every 360 degrees, and that's what we talk about the period. Now, what I find that students often get wrong is that they say that the period is a set from one value to another value, and the period doesn't ask for a set. The period is just one value, and it's an answer to the question, how many degrees does it take for the curve to repeat itself? Simple. So it takes a fixed number of degrees, and for the sine graph, it takes 360 degrees. So this is very important because we're going to look in a moment at period changes. Okay? So we've got the period is 360 degrees. We've got the range is -1 to 1. And the domain, obviously, it could be any value. And let's look at now the interesting part. Okay, and that was all grade 10. Let's look at what transformation exists when you take a value k and you multiply that by the angle. What do you think is going to happen to the curve that we've just drawn? I'm just going to extend the page here. Let's just go there, and let's just... No page extender. Okay. Right, so let's just write this again. So let's, for example, look at what would the graph of y equals sine 2x look like? Do you think that the period would grow, or do you think it would shrink? So earlier we said it would take 360 degrees for the graph to repeat itself. Would it grow or would it shrink? What is the effect that this coefficient has on the period? Okay, so we'd like to know what is the effect of the coefficient of the angle. Okay, and to do that, you would actually point plot. You would take every single x value, you would double it, you would take the y value, and you would plot the curve. And we're going to do that for one, and then we're going to hope, similarly, we're going to be able to do that for the other graph. So we would start off with a value, and I'm only going to do a certain section. I'm going to start at 0, and then I'm going to go to 90 degrees. Actually, I'm going to, yeah, that's fine. 180, 360, and just so that we can have a couple more values, I'm going to put in a few more in between, which are our halves. So that would be 45, 135, 225, etc. Okay, so if we took an x value, any of these x values, could take 45, and we double it. 45 times 2 is 90. And what is the sine of 90? It's 1. So at 45, I've got a value of 1. If we take 90 and we double that, we get 180. And the sine of 180 is 0. So we now have got a 0 through here. 135 times 2 is 270. The sine of 270 is minus 1. 180 doubled is 360. We've got a 0. So look what's happening to the curve from 0 all the way through to the 1, coming through to -1 and up there again. And then it's obviously going to repeat itself, so it's going to do the same thing, to 1. It's going to come down, and it's going to go up again. So we should have, yeah, here should have been a -1 here, and we should really have 360 here, because we should have actually had a 270 here. Right, so the curve still has a maximum at 1. It still has a minimum at -1. But whereas before it was taking 360 degrees to repeat itself, it's now taking 180 degrees to repeat itself. So the coefficient of x, which was 2, has actually done something to the period. It's halved the period. And so the function of that coefficient will actually do the inverse property of the period. Okay. So we can now say that the period of a sine 2x graph is 180 degrees. That means that your period for y equals sine kx, look what happens. The coefficient was 2, the period became 360, or if we just show 360 divided by 2, it's the inverse of the coefficient of x, which means that if we want the period of this graph, we are going to say that it will be 360 degrees divided by k, whatever k is. Right, so let's look at the graph y equals sine 2x. We've just plotted it. We've seen that the period is 180 degrees. But let's look at how you would sketch that graph if your examination paper asked you to just get y equals sine 2x without point plotting, but just using the features of the quadrant angles, because that's really all that you need. So you would say the coefficient of x affects the period. Okay, and your period is now 360 divided by 2. Now, in that cycle of 180 degrees, you need to get the y values that you need to get, the maximum and the minima, would be, you would have a 0, it would grow to 1, it would decrease to 0, it would go down to its minimum, and it would go back to 0. So in the space of 180 degrees, you need to get 1, 2, 3, 4 values, the critical quadrant angle values in that space. So you then do something very neat, which says I need to get 4 values. How many degrees am I going to plot? I'm going to plot every 45 degrees. So that's the only knowledge you need to know. It's the period, because from the period, you're going to plot your quadrant angles. So our quadrant angles have changed, and our graph now looks like this. I'm going to start at 0, and because I need things happening every 45 degrees, I'm going to plot 45, 90, 135, 180. And on the left of 0, I'm going to do the same thing. Negative 45, negative 90, negative 135, negative 180. And then we said we only need the y values, which start at 0, they grow to 1, they come back to 0, they go down to a minimum, and they go back to 0. And then you would join those with a free hand, not with a ruler, and you would do the same thing here. Now here, it can't grow up, because it's got to first come down to a minimum. So it would grow, it would come down to a minimum. Okay, it would go to 0, grow to a maximum, and then come back to 0. So it would then go there and come down. Okay. So this graph has been repeated on the left of 0 and on the right of 0. And I'm saying to 1, and I'm assuming that there is a y-axis, and there is a 1 here, and there is its minimum is minus 1. Okay. So the range is still minus 1, 1. The coefficient of the angle does not affect the amplitude. It only affects the stretch. So that graph, actually the period, affects either a shrinking or an expansion of that graph. Okay. Now, let's look at what happens if there was no coefficient, but now you were adding something onto that angle. What would happen? What do you think would happen? Okay, and for that, we're going to also play. We're going to play with a function. We're going to say, well, if we're at 0 degrees, and we're going to take an example. So let's look at y equals sine of x minus 30 degrees. Okay, and let's take x as 90 degrees. I would then have, if I would have a 0 here, or let's say, let's start with 0. If I had 0 degrees minus 30, I would get negative 30. What is the sine of negative 30? It would be negative a half. So I'm actually starting my graph at negative a half. What happens if I said 30 degrees minus 30? Well, 30 degrees minus 30 is 0. So at 30 degrees, I'm actually getting a 0. What about 60 minus 30? That would give me 30 degrees. So at 60, I would get a half. And what would happen at 90? 90 minus 30 would be 60, which is about root 3 over 2. And then eventually at 120, I would get 90 degrees. So I would get my 1 there. Okay, so see how this function has actually worked its way to a maximum from the 0. So if I had to sketch just y equals sine would go from 0 to 90, from there all the way to 90, to its maximum over here. Okay? And look at what's happened to the white values. They've been translated to the right by 30 degrees. And isn't that something that you would expect to happen? Because the value of that constant that's attached to the variable, whether you're in parabola language or hyperbola language, doesn't matter where you are, it always goes through to either the right or the left. There's a translation, there's a horizontal translation. Okay? So the yellow graph would just be y equals sine x. The white graph is a graph that depicts that every value has shifted so that the maximum now is happening 30 degrees after where it usually happens, when it's just the parent graph. We call y equals sine x the parent graph. We will derive every single graph from that one. So that the parent graph has been shifted 30 degrees across. So if we're saying that a horizontal translation occurs with x minus 30 to the right, then what would you expect to happen if I had the graph y equals sine of x plus 30 degrees? How do you think that that translation would behave if I had x plus 30, seeing that the x minus 30 is translated 30 degrees to the right? And I think I'll leave it there and we'll take a little break, and then when we come back, we'll see if you've managed to answer the question.
Yes, guys, we're going to go to a break now. Remember to keep sending in your questions on Twitter and Facebook. Remember that today we're giving away a Casio calculator to the lucky grade 11 learner with the best question. And see you after the break, guys. Welcome back, Mindsetters. Today we have a fantastic surprise. We have another labeler. This can go to the grade 10, grade 11, or grade 12 learner who's the best mindsetter on the planet. Now, the more you engage, the more you type in your questions and your answers and everything, the more the more chance you stand to win it. And we'll be looking out today. We'll be looking out for the best question and the best interaction ever. So make sure that you give us your all and give us all your comments and your motivations to other people as well, because that counts a lot. And we're going to get back with Dina for grade 11 Trig.
Welcome back, everyone. So how did that go with your y equals sine of x plus 30? Okay, before we go there, I just want to show you what the graph of y equals sine of x minus 30 looks like, and then we'll look at yours. Right, so this one that we left you with, let's just go and erase that. That was actually minus. So let's say that that's minus 30 degrees. Really, really, really. Okay, so the green graph shows that translation, that every single value that's been plotted has been shifted across 30 degrees. So the zeros have been shifted across 30 degrees, the minimums have been shifted across 30 degrees, and that's been shifted across 30 degrees. And notice that the 0 here, between 0 and 30 degrees, have also been shifted. The yellow one is our parent one, y equals sine x, right? And then we left you with y equals sine of x plus 30. Okay, let's just make it white. Y equals sine of x plus 30 degrees. And what would happen to that graph? Well, if the translation now happened to the right, this translation has got to happen in the opposite direction, so it's going to happen 30 degrees before. So where the maximum was at 1, it's now going to happen 30 degrees before. And where it was at 0, it's going to happen 30 degrees before. And where it was at -1, it's going to happen at 240. And where it happened at 360, it's going to happen at 330. So this white graph is going to be the graph of y equals sine of x plus 30. Notice how I've just used the quadrant angles from the parent graph. I haven't sat with my calculator and plotted the points and wasted a lot of time. So you take the parent graph and you just sift your graph either right or left based on those values. Now, Katlego mentioned that there were some queries around where does the 2 come from and where does the 4 come from. The 2 was given. You cannot make that up. So if you were given the graph of y equals sine 3x and you wanted to work out the period is always denoted by whatever the coefficient of x is. That will tell us what to use. So that's why I used 2, because it was sine 2x. And if you used sine 4x, then the coefficient would be 4. So the coefficient of the angle will be what you extract in order to get the new period. So the period is always the period of the parent graph divided by the coefficient. So in this case, it would be 120. So where did I fetch the value from? It's given to you in the trig function. Okay. Now, where did I get the 4 from, and why did I divide by 4? Because when you start at 0, you then need quadrant 90, quadrant 180, quadrant 270, quadrant angle 360. So there are 4 quadrant angles that you need to plot. And those are the selected values that are useful to plot when you're plotting the transformations. So I use the value of 4 because there are 4 quadrant angles. We don't count the 0 because we start counting with a 90 degree. The 0 is where we start off with a graph. So we need to plot a 90, a 180, a 270, and a 360. There are 4 quadrant angles. And so if I took 120 and I wanted to know where would my new quadrant angles be, then my quadrant angles would be defined by 120 degrees divided by 4 because there are 4 of them. Okay, and I hope that answers that question. And so I would then be plotting every 30 degrees for the transformation when you've got the 3x. Okay, right, so let's have a look at the COS function and how that behaves. What does the COS function look like? Is it very similar or very different to the sine graph? Well, they're kind of cousin functions because they also oscillate. The COS oscillates between -1 and 1 as well, so the range is the same. The only difference is that their 0 degree angles are different. So you would start at a different place, but they would still move in the same way as the sine values move, and that is that they would decrease to -1 and increase to 1, etc. So it behaves very much the same way as your sine curve, which means that their transformations will behave in the same way. And so let's have a look at what the parent graph looks like for the COS graph. So if I started off with 0, and I had a 90, 180, 270, 360, then my COS parent graph starts at 1. At 0, it then comes through to a 0, and then it hits its minimum, then it goes through, and then it ends at a maximum. So it oscillates between -1 and 1. This would be 90, 180, 270, and 360. Whereas the sine graph, if we draw that in green, the sine graph would start at 0, then it would hit a maximum, and then it would come to a minimum. So their maximum and minima at different places. Okay, so yeah, they share some values, and I wonder if anyone knows out there what is the value that they share. So they intersect at those values. What would that be? I'll leave you to ponder on that one. But that would be the sine. So at 0 degrees, sine would be 0, but cos would be 1. And so that's really the difference. And then so if it's got a maximum, it then is going to go straight to a 0, because you can't have its maximum and then go up more. So it would go down to a 0, come down to -1, 0, 1. So that would be my COS. Right, so let's look at an example of what the transformation for kx would look like. And let's look at y equals COS. We used 2x with a sign, so this time round, let's use half x and see what happens there. So x over 2. Okay, what is the, and I'm just going to rewrite this. This is the COS of a half x. What is the effect of that half on the angle? Okay, so before we can answer that question, we need to look at what is the period of a parent COS graph. COS also takes 360. Remember, sine and cos are really cousin graphs. They kind of have similar, or they've got some similarities. The period being one of them, that the period is also 360. So it takes 360 degrees for us to see a repetition of any of those values. So the period of the parent graph is 360 degrees. Remember from the sine, we said that the effect of that coefficient of x is that it will affect the period inversely. So if we divide that by half, I'm getting it from the given function. That's where I'm picking it up. That's why I'm dividing by half. 360 divided by half is 720. So what we're now saying is that it's going to take us 720 degrees for us to complete that curve, that COS curve. So the maxima, the minima, they're going to shift and they're going to expand into that 720 degrees. Okay, so where are we going to plot? The next question is, where are the values going to be plotted? Okay, and for that, we will take our 720 degrees. How many quadrant angles are there? There are 4. That never changes. That's fixed. So we're going to divide that by 4. And what do we get? Well, that's 180 degrees. So our quadrant angles, which for COS, if we go up, for COS would happen at a 1, 0, minus 1. So the order would be a max, a 0, a min, a 0, and a 1. So I would plot those values, and where would I do that? I would plot them every 180 degrees. So I want to set my axis up in units of 180 degrees, because I'm only going to plot every 180 degrees. So I'm not going to set up my axis before I've decided how I want to set it up. So it's a waste of time if you start with 45s or even 30 degrees, because I don't need those. Those are irrelevant. We only want our quadrant angles as significant points, or as critical points, to show us exactly where to do that. So let's go to the Cartesian plane then, and we would start at 0. We would have 180 degrees. We would then have 360. 540 and 720. And how are we plotting them? We're starting at 1. So on the y-axis at 1. And let's plot it in yellow. So we'd have 1. And then we'd go down to 0. And then we'd go to -1. And then we go back to 0 and up there. Okay. So the graph would oscillate. And then it would obviously carry on depending on what the domain is. I'm only showing you one cycle, one periodic cycle, because once you've got that periodic cycle, you can then repeat that on either side. Okay? So we've got max, 0, min, 0, 1. And that's why I've divided by 4, because there are 4 quadrant values that are significant in our plotting. If we have all these values in here, all they're going to do is they're going to show that that function decreases to that 0. But they're not relevant points. Your quadrant angles are relevant points, and that's where that 4 is coming from. Okay, so let's then go on to a trig function that involves cos, but it involves a value of x plus p. And again, let's give ourselves an example. This time round, we used 30 degrees with sine. Let's use y equals cos of x minus 60. Is there anyone who would like to venture as to what would happen to the parent graph, the cos parent graph, to give us x minus 60? What do you think would happen? Well, let's go back to our sine. If the sine showed a translation, and if x minus a value or x plus a value shows a translation, then all we need to know is which direction that translation is in and where the new zero would start, because the period will not change, and that's very important. So this period is still 360 degrees. So from wherever you start, you still need to work with 90 degrees separating every max or every critical value or every quadrangle. Still has to be separated by 90 degrees. Okay, so let's have a look at what that would look like. Okay, let's first of all just sketch the COS graph, the parent COS graph. So it would do that, and it would come there, okay? So that would be 90 degrees, that would be 180, that would be 270, and that would be 360 degrees. Okay, now we want to show what would happen to y equals cos of x minus 60. Okay, x minus 60, watch very carefully. If x is 60 degrees, then we would be plotting our zero value cos 0. So we want to start this graph, this one that started on 0, we now want to start it at 60 degrees. So at 60 degrees, it's going to have a new maximum. So it's going to shift, that naught has now shifted to 60. In order for me to get a cos naught, x has to be 60, which means that this value here at 90 has to move to the right by 60 degrees. And 90 plus 60 is 150. So at 150, it's now going to go through naught. Okay? This 180, where the minimum was happening, it's going to happen later. So at 240 degrees, we're now going to have the minimum. 270 degrees, this 0 is going to happen 60 degrees later. 270 plus is 330 degrees. So at 330, we're going to have a 0. And 360 plus 60 is 420. So this graph has a cycle from there through here to 1 there and up. So you can see that nice shift. That curve has just shifted over 60 degrees, which means that if you took 0 degrees, you'd get the cos of negative 60. And the cos of negative 60 is a half. So the graph actually comes through a half as well, because then you can work out what your intercepts are. Okay? And then it carries on. You would take 60 degrees and you would move 90 in order to get the next 0, and 90 degrees and 90 degrees. So you'll see, this is now 150. We've shifted it 60 degrees to the right. We said this was 240. We said 60 degrees to the right, this was 330, and we said that was 420. But notice what is the difference between this maximum and the 0? How many degrees are separating them? 90 degrees. How many degrees are separating 150 and 240? 90 degrees. Remember, your quadrantangles haven't changed. They still every 90 degrees, because the period doesn't change, because x's coefficient is still 1. If you affected that coefficient of x, it would also affect the period. However, we don't look at those transformations in grade 11, but it would be something interesting for you to go and sketch on your own. What would the graph of y equals sine or cos of 2x plus 30 degrees look like? And that would be quite interesting to look at. Okay, so we've got the quadrant angles happening if you set your 0, if you set your new maximum with its new 0 of 60 degrees, then the next value has to happen 90 degrees later. So if you add 90 to that, you'll actually get the 0. 90 to that. You could either do that, or you could shift all those parent values along as well as a checking mechanism to see that you've actually got the right values. So we go all the way. So this one would be cos x minus 60. Right, and then just to end off, what would then the cos of x plus 60 look like? Okay, so you can take a break and have a look at what that looks like. Over to you, Tlehu.
I really like these break challenges. I think they're great. You guys, you grade 11 mindsetters are so alive. It's so nice to see. Make sure you get some refreshments and do this challenge question for the break, and we'll see you after the break. Welcome back, Mindsetters. Hope you guys are all refreshed and ready to roll. You guys have been so interactive today. Like, time is just going so quickly. We're chasing after time now. Dina, over to you.
Katlego, there's just far too many questions to go over. But the question that was sent by one of the Mindsetters is, what is the difference between amplitude and maximum value? Okay, so for that, we have to look at the definition of amplitude, and it's a very scientific term, really. And the amplitude has got some connection with the maximum value because it's defined as a distance. So it's the maximum, if our pen cooperates with us, then we can say it's the maximum distance above, that the graph reaches above the x-axis. But if you had to look at the synonym for the maximum distance above the x-axis, then that would really represent its maximum value, wouldn't it? Okay, but we don't define the amplitude as the maximum value. We define it as a distance that the graph has to travel from its rest position to the maximum value. And because it's a scientific term, the scientists use a lot in terms of wavelengths and things like that, so we'd like to keep that pure definition of the maximum distance above the x-axis, and that distance is really defined by its maximum value as well. I mean, the words, the definition has got the maximum in it, so obviously it's interrelated, the maximum value as well as the amplitude. But you'll see two questions. You'll see what is the amplitude of the graph, and you'll say it in terms of a distance. So you cannot give it as a negative because it's the distance, so it will always be positive, whereas the maximum value of the graph is just a function value, and it would be in the range. So just be careful which question you're answering when you're actually answering that. And then we were asked about this graph, which shows two transformations, and I haven't really dealt with the coefficient of the function, but that coefficient does affect the maximum value, and it affects the amplitude as well at the same time. And since I've got this minus 30, I've actually got a horizontal translation as well, and I will leave it up there as a challenge question, and see if any of you can kind of sketch that graph, because I'd like to actually get involved more with the little issues around the sketching and why we divide by 4 and where do we get the half from and those kind of things. So I just want to see from Klehu if we've got any mindset or questions that we can take.
Yeah, we do. Let me just check for you. I think there's quite a few. Oh, I've been getting this question quite a lot.
Yes.
Why are you dividing by 4?
Okay, so I'm going to take an example. Y equals sine x. And I'm going to look at why did I divide by 4 in order to get my quadrant angles. Okay, so if I took my parent graph, okay, and everyone knows from last year what this graph looks like. So I would have a 1, I would have a 90, I would have a 180, I would have a 270, and I would have a 360. Okay. To get a complete cycle, to get a complete sine cycle, how many quadrant angles do I have? 1, 2, 3, 4. That's where I'm getting the 4 from. The fact that the parent graph has 4 quadrant angles that give us very special values. They're not just arbitrary values, they're very special. At 90, I get a max. At 180, I get a 0. At 270, I get a minimum. And at 360, I get a max. And then it repeats itself. So its period is 360 degrees. So my sine curve goes through 90, one value. 180, second value, 270, third value, and 360, fourth value. So it goes through 4 critical quadrant angles for me to get its shape. And then it starts repeating itself. And so that 4 is an interpretation that every other graph that you draw where the period changes will have to have 4 quadrant angles that you're drawing in one periodic cycle, because obviously those are going to be repeated to the right and to the left as you go from both negative infinity to positive infinity. So I hope that answers the question where I'm getting 4 from. It's from the parent graph, where I go through one value, 2 values at 180, third value at 270, and the fourth value at 360. So I want to mirror that transformation, or I want to mirror that parent graph's values onto the transformation. And so when I take it across the transformation, I want to see what happens to those quadrant angles. I want to see what happens to each one of those quadrant angles in the new transformation. And so the unique way of understanding that is really when you've got y equals sine 2x, because that 2 is going to shrink the graph, because the period is going to be 360 divided by 2, which is 180 degrees. I want to know, in 180 degrees, I have to get a complete sine curve. That means I need a max, I need a 0, I need a min, I need 4 critical values. Where are they going to happen? Can you see why the 4? The quadrant angles need to be prominent in this decision-making of where it's going to be. So 180 divided by 4 is going to give us what I'd like to call the new quadrant angles of 45 degrees. So we're now going to plot the first one at 45, the second one at 90, the third one at 135, and the fourth one at 180. Without those 4 values, I can't repeat the cycle either to the left or to the right. So the parent graph had 4, and every transformation will have 4 as well. Hope that makes sense. Let's take another question, Katlehu.
Okay, another question. Everyone's just answering your questions. It's so fantastic. I don't know if you've gone through the parameter, but there's a question on that. Now that we say we are working out the effect of parameter p, which other parameters effect can we work out?
Okay, right. So I've only worked on 2 today. I've said y equals sine kx. In other words, nice language there by mind-setters. I like that. The parameter. The parameter is that which changes, and the parameter k in this case is the coefficient of the angle. So we've worked with the coefficient of the angle. Okay. That's the parameter that affects that shrinking of the graph or that expansion. So 2, for example, will make the period 180, but a half will make the period 720, like we saw in the COS graph. Okay? So that's parameter k. We also looked at y equals sine x minus p, or x plus p, doesn't really matter. And the parameter in this case was p, and that is a constant that's added to the angle. Constant added to the angle. So in this case here, the coefficient of the angle means that k is being multiplied by the angle, whereas here it's being added to the angle. And so this caused, okay, so let's just write down what we found. Let's try and summarize. Here, this parameter affects the period. So the period is affected. How is it affected? By taking the period of the parent graph and always dividing by whatever k you're given. Because a number of you said, where did I get the half from? Why am I dividing by half? Why am I dividing by 2? Well, we were told sine 2x. We were told cos a half x. So you'll be told what that k is. Your job is to then take the period and divide by that given k value. So it's not made up, doesn't come from the sky, it's actually there, you'll see it. And this parameter affects the horizontal translation. Okay. What the mindset has asked is, what other parameters are there? Okay, and I'm only working with sine, so this would happen for cos and tan as well. So what other parameters do we get? What others exist? Okay, the first one is you can get y equals k times sine x. So it's the coefficient of the trig ratio. Coefficient of trig ratio. And in the challenge question, I left you to figure that one out. How does the coefficient of the trig ratio affect the graph? And the second one is y equals sine x plus p. Okay. So it's a constant added to the ratio. Added to the ratio. Okay, and you are going to deal with those in class, the coefficient of the sine of the trig ratio and a constant added to the trig ratio. But I think that you'll probably notice that this is very familiar to those functions that you've worked with in algebra, your parabolas, etc. What happens if you just add a constant to that to that function value? What happens to it? Vertical translation. So this one will exhibit a vertical translation, and this one will stretch the graph up or down. So this will affect a stretch, a vertical stretch, and it will therefore impact on the amplitude. Okay, so those are four major ones. Any other questions?
No other questions, but the challenge question, there's been answers to that. Maybe we can do that.
That's very difficult to draw. I'd like to take one of the callers or one of the mindsetters' answers and see what they came up with. Right, how much time do we have?
I think we have about less than 3 minutes.
Okay, let's see what we can come up with. Okay, equals 2 sine x minus 30 degrees. Okay, is anybody responding? Are they telling us how they would like to sketch it? What are they saying?
Tivani just shouted, it will shift 60 degrees, and everyone's saying it will shift to the right because it's a negative, and yeah.
Okay, it will shift to the right. That's great. 30 degrees to the right, because remember, if x is 30, 30 minus 30 will give me sine naught. And we always start at sine 0. If we zero our value, then we'll know how that graph has shifted from 0. So zeroing the value means x has to be 30 degrees. So it will shift 30 degrees in order for you to get 30 minus 30 to be naught. If you said this was 60, 60 minus 30 is 30, you're not getting a 0. You need to get a 0 out of here. Okay? So I liked what they've said about shifting. What are they saying about the 2?
They say, okay, let me read. Ebenezer's answer is a very good one. If the function is what she said, the parent graph will shift 30 units to the right and 2 units upwards, i.e. the amplitude will be 2.
Okay, I just want to look at that language. Shift 2 units up. Okay, what do you mean by that? Does that mean that if the parent graph does that, then we're going to see this new graph going up? That was 2 units, going to go up 2 units. This was 1, so it's going to go up to 1 plus 2 is 3. So this is going to be 2, and this is going to be 3. So is that what's going to happen to the graph? Okay. Ebenezer, just be careful with language. Shifting 2 units up in mathematics means that we see that shift. We see everything goes up. It's like climbing stairs. You're going to go up. Okay? The graph actually doesn't shift up. It stretches. We talk about stretches, 2 units. So you're going to pull it from 0, and then the maximum is going to go up to 2. So the graph is going to do this. From there, all the way to 2, and then to 0, there and there. So it's going to stretch. Can you see that stretch? Okay, so it doesn't shift, it stretches, and then it's correct, it's going to translate to the right, so it's going to do a 30 degrees, so it's all going to move right, so it's going to do something like that. Okay, so it's going to stretch and translate. Well done.
Wow, that's a fantastic show, guys. It was really awesome. Your questions and your answers were fantastic. You guys were on the ball today, grade 11s. Remember to tune in next week for some more. Thank you so much for a fantastic show, Dina. We really enjoyed that. I know every mindset enjoyed that. See you next week, guys. Tune in for grade 12 maths. Bye.